About a year and a half ago, I felt completely exhausted by woodworking. I had just completed a set of 6 bullback chairs designed by Thomas Mosier, a complete dining room set. This is a project that took me 4 years, and I decided to put woodworking aside, so I've done a lot of other things since then. I started this YouTube channel, Frankly Fukuyama, and I've acquired a lot of gear for it. One of the things that I decided that I would try to make is a camera slider. A camera slider is simply a linear rail that moves the camera up and down or back and forth so you can have panning shots. Rail was made by Open Builds. I bought the rail. I had an old NEMA 23 stepper motor, which is the motor there. It's a fairly large one. It's driven by a motor driver. The motor driver is connected to an Arduino. The Arduino has an auxiliary 5-volt regulator. It takes juice from a 24-volt 6S quadcopter battery. If I plug the battery into the stepper, it starts rotating the stepper motor, and the platform begins to move down the track. Although it may not be obvious, I've actually made quite a lot of progress in this machine, this camera slider, over time. So I added a shield to the Arduino. Turns out I needed too many wires going into it. This simplifies things because it's got the SparkFun Quick system that allows me to hook up things like this LED screen with just 4 wires. There's a voltage regulator. This is actually the motor driver for the latest edition, which is this rotating platform. It's a panning mechanism to which you can attach a camera with an Arca-Swiss clamp. It has a little 37mm spur gear motor that rotates the platform. I turn the slider on, and the first thing that happens is the panning mechanism starts rotating so that the camera can be placed in the proper position for a homing position. And then you hit this homing switch and it stops. And now the slider itself is homing. Homing simply means that it's finding the end of the rail where there's a homing switch, and as soon as the carriage hits the switch, it all stops. And at that point, you'd be set to start your video camera. And there's a switch on this plate, and you push that. And then the slider starts moving across the track, and the camera mount starts panning. I've now completed enough of my slider project to say that I'm at version 1.0. The main thing I've been doing in the last couple of weeks is to put all of the control components in this box that's got the Arduino and the motor driver and the voltage regulators and so forth. They're all connected by detachable cables to the slider unit. So this is what the control mechanism looks like when you open it up. It's a big tangle of wires and components. One of the big problems was figuring out how to attach the slider to the tripod because it's very long and unbalanced. I finally figured out that the best method for doing this would be to buy an iFootage spider crab mount. Well, I guess it's a leg. It attaches to the bottom leg of the tripod and then has an extremely clever locking mechanism. Actually figuring out how to put a Arca-Swiss plate on the bottom of the slider mechanism was also a bit of a challenge. I ended up buying 1/2-inch acrylic, drilling it, and putting a female screw, 1/4 20 screw adapter. The mechanism works basically the same way as I demonstrated earlier. You turn it on. You can then get a readout as to what's happening, and the panning mechanism rotates the camera. When it's rotated to the appropriate angle, you push this switch. It begins to home to the end of the track where it engages the homing switch. At that point, you push this large button and it begins to move. And it accelerates up to a speed and to a distance that is set by these different knobs. So this one determines the span that it's going to reach. Here you can see it's 211,000 steps. This knob controls the speed of the panning mechanism. So this short segment just shows how the slider works. The camera is panning across the table and rotating slightly. The mechanism isn't quite right because the panning is a little bit too fast for the speed of the horizontal motion, so I've got to change the gearing ratio a little bit, but otherwise it's in pretty good shape.